Hi and welcome to this video in the MRDCL Concept series. In this video we're going to look at some of the disciplines you should be considering if you've got big runs and really some tips on how to make your runs more efficient. If you just run small projects that all run in a few seconds, this video probably isn't for you. It really is about people who have got very big runs where they've got huge repetitive bits of code, big variables, large numbers of tables, and large numbers of records, any of those sorts of things. Because what we found is that sometimes just by making or understanding the things that actually can take a long time and actually using code more efficiently, you really can bring down your run times. We have had occasions where we've reduced run times to something like sort of a 20th of the time it was taking. And if a run's taking 2 hours to run, that can be obviously quite significant while you're sitting waiting for a run to complete. I think this really applies to any runs you've got over 1 or 2 minutes. I would start to look for efficiencies because it really does make a difference. If a run can just go through in 10 seconds, that's a lot different from a run that might take 3 or 4 minutes, where if you're running it several times, that can have an effect on how much of your day gets chewed up by correcting errors and so on. So these tips are only for those sorts of people. If you're doing small projects, I really wouldn't pay too much attention to these things unless you think you need to keep them in the back of your head or make it good practice that you use. All right, I haven't got a big project in front of me. I'm just going to really use this test project for illustrative purposes so that you can see some of the techniques that we can use here to improve things, and I can refer you to some other videos in our series here that will help you. So let's look at this project first of all. You'll find the files for this project in PRJ 103. So let's make a start on this now. You'll find the files for this particular project in PRJ 103. As I say, mainly it's a visual video, this, where you can you can see the things being demonstrated as we go through the video. Probably the biggest thing to take a note of and be concerned about is big multi-variables. They take up a lot of space. Those of you who use SPSS, for example, will know that a multiple variable in SPSS will take up as many fields as there are codes in the variable. Now, if a multi only has 7 responses, that's only 7 fields. But if you've got a brand list of 5,000 brands, that's 5,000 fields, and suddenly a data file gets very big and unwieldy in SPSS. It's not as bad in MRDCL because you can store the data effectively, and the impact is probably much more reduced because of the efficiency of the way it handles multiple variables. It's not tying things together. Nonetheless, big variables will be less efficient to process than big single variables. So if you've got a question saying, what is your favorite brand? And that's a single response answer, that will process effectively like an integer because it's just holding a value for that variable. Whereas if they can choose as many favorite brands as they like, you'll find that that means that you've got to be able to store, in theory, up to all 5,000 of the brands if there's 5,000 brands in your brand list. And that becomes a big variable that has to be carried around by MRDCL through all stages. So that big variable ends up on the IDF. That's a big table that it's got to do a table on because it's now got 5,000 rows. It'll make a big ITF when it comes to produce the tables, and it's got to format it with all the format options that you choose, and it's got to apply that to a big number of rows. So big variable, when you've got big variables, that should always sound alarm bells to you, and you should start to think about, well, am I doing things in the most efficient way? So that's my first thing first trigger is always big variables. And I've seen this badly abused in cases. I've seen people who, for example, will do something like this. So they'll say they've got Q99 and they'll dummy define it, let's say 5,000 responses, because they don't know how many codes are going to be in their code list later. So they've dummy defined question 99 as 5,000 codes, just so they've definitely got enough codes when they come to perhaps do coding and they want to back code answers perhaps from text responses from a spreadsheet into Q99. Now, I have then seen that people perhaps only use 30 of those codes. That will be very inefficient use of MRDCL. You're basically asking MRDCL to handle a big variable when actually it's quite a small variable and you've just set a ridiculously high limit. And indeed the limit for a variable is 9999, and I have seen people just set every dummy variable to 9999 because you can. Now that won't particularly matter if you've got 1, 2 or 3 variables set to 9999, but if you suddenly have got 100 of them, you'll suddenly find your run behaving quite slowly because it's carrying around the equivalent, that's almost the equivalent of 10,000 single variables. It's not quite, but it's similar. So it's a huge amount of data that you're asking it to carry around once you set variables that you don't need. So be realistic. If it can be 99 rather than 9999, make it that, because it will be a lot more efficient. Don't go and just specify a big variable because you can. Think about it. If it's one odd variable, it probably doesn't matter much. It won't slow your runs down. But if you suddenly put 100 of them in there and you've got 100,000 respondents, you probably just wasted every time you run it, I don't know, an hour or so of your time just because of that inefficiency. So that's the first thing to say, and other things go along with that. I've seen people define variables where perhaps there's a lot of temporary variables could be used. So let's have a look at how we might do that. And for this example, I'm going to imagine that we're picking up perhaps the first, second, third mentioned brand and any other brands that are mentioned. So we might have something like this. We might have the first brand in 11 to 14, and we might have 9,999 brands. The second brand in 15 to 18, and the third brand in 19 to 22, and any other brands. Now we could store those as a series of ones and zeros. Now that would be inefficient data storage because it would effectively allow for all 10,000 items, or 9,999 items, to be chosen. I would, if you can control how the data's output, I would very much recommend that you store it as a spread field, and let's say the most that anyone gave would be 50 different answers or 50 different brands. Even that sounds unlikely, but let's assume that's the maximum. And just for clarity there, what a spread field is that it's going to store the first brand that's encountered in 23 to 26, the second brand in 27 to 30, the third in 31 to 34, and so on for 50 blocks of 4 columns or fields. And now if I want to get all brands, I might define it as M1 or M2 or M3 or M4. So that's the sort of code, and obviously then you'll have below that a whole series of 9,999 texts that pull that in. And again, I would recommend that you do that from a spreadsheet or at least a CSV file to make that efficient. Now that's all fine and that would work, but there's a lot of inefficiency here, and let's look at some of the things we can do to improve this. Well, first of all, these variables here very much should be set to singles because they really are. There's only one answer there. Just because they're in a pattern, it might be tempting to write a loop or something like that pick them all up as multis, but really you're just wasting a lot of processing time there. Again, particularly if you've got a lot of variables like this or a big data set that you're processing. This is more unavoidable. This variable we have got to pick up as a multi. There's nothing we can do about that. But it's highly likely that you don't actually want to do a table of the other brands. All that you probably want is a table for the first mention, the second mention, third mention, and all brands mentioned. If that's the case, I would make that a temporary. So put an X on the front of it, and by default an X on the front of a variable name means that it's a temporary variable, which means that it doesn't carry it around with it. It doesn't go on to the IDF. It's not being processed in the table stage. You're just making your run much more efficient because in this example we've gone from 5 multis to 3 singles and 1 multi that gets carried through to the IDF and into the table stage. So we've already made a huge efficiency here. Now, if this was repeated many times, that would, really start to make an IDF and a run quite big, especially with large data sets. If you run out of temporary space, as it is possible to do, you can increase that with a temporary statement that looks like that, and that will increase your temporary space for you so that you can have plenty of room for more variables. And that will just work just absolutely fine. There it is. It's produced my run. It hasn't actually done it with the tables there, but it's handled that quite efficiently, and that's a good way of working. Now, the next thing that's worth looking at is compilations can start to take a long while if you've got a huge script. And there's a couple of things that you can do there to improve your run times. Now, as you probably know, when you're compiling a script, everything ends up in the listing file. Now, again, that usually doesn't matter, but if you've got something like a long brand list that's getting repeated several times, that can start to make the listing file get extremely long. And I have seen listing files that run over 1 million lines where there's lots of repetitive bits of text being output. If you know a piece of text works well, one of the things that you can do, or sorry, a whole chunk of code works well, there's a couple of tricks that you can use. So one that I use is if I know perhaps this section has been run many times every month and it's unlikely not to compile, you could put nlist around a whole chunk of code, and it's not very much here. So say that this chunk of code here that I'm putting the nlist before and the LST back afterwards, let's say I've run this chunk of code hundreds of times every month and it hasn't changed, it's fairly unlikely that's not going to compile. And if I put an nlist around it, it does make it more difficult to find the errors because all you get is a warning in the log without too much identification. But if you're highly confident this is not going to fail in compilation and you won't want to look at this chunk of code in the listing file, you might consider putting an nlist around it. And one thing I often do is if I've got a long brand list of let's say 5,000 brands, I actually put an nlist around that code because I just don't want to see it in the listing file. It's going to waste its time writing that out. So say that brand list is repeated 50 times. I really don't want to see it 50 times coming out in my listing file. It's just wasting thousands and thousands of lines of time writing that all out. And there's even some tricks you can do there. If you've got something like a brand list that you're using over and over again, I would always recommend taking this piece of code out and putting it into an insert file like this, opening up a new file called brands.stp, pasting it into there, and then I can reuse that brand list as many times as I want to. Actually here it's quite efficient, it just says x equals q1, but if I wanted to I could just insert the brands and it would automatically put them in there for me. And I could even then inside here just put an nlist around that. So I could say f equals nlist, f equals list, and although it's a little bit more work, it will save all that code coming out in the listing file, and the preprocessor will just pull in the brand list for me. So there's some tricks that you can do there that will save runtime. The other thing that people often complain about when they're running particularly a tracking study and they make a few changes, it takes maybe, let's say, 20 minutes to compile a huge project that's got thousands and thousands of lines of code in it, is that they make one error and they have to wait while the run gets to the end. If you're confident that the errors are going to be very small numbers or they're going to come in one cluster, there is a format option that I use sometimes called EMU, or EMU we call it, there's a bit of fun there, which means Error Monitor Upper Limit. And if you set that to 10, the run will abort if it finds more than 10 errors. So if you really don't expect any errors in a run, you could put EMU1 in there and it will just crash immediately so that you can rather than waiting for it to do the whole compilation, you can look at that error, fix it and run again. And that, again, can save you some runtime when it comes to running your tables or compiling your tables more accurately. The other tool that you've got that's a little bit similar to this inserting of brands, I have seen cases where you perhaps get huge numbers of rating scales. You can't avoid making them multis, so let's say we've got a loop here. I'm going to do a 1 to 100 where you're picking up rating scales. So you might have something like Q10 underscore A is $A plus 201, and you might be picking up 1 to 5, 1 to 2, 4 to 5, so you get some subtotals, and the labels in here would be very good. I'm not going to, I'll put some scores on very quickly. V2, quite good. V1, neither. V0, quite poor. V minus 1, very poor. V minus 2, and not. We didn't do not so we've done subtotal net good, which doesn't get a score. Net poor, and NS. And I'm going to call this Q10, and I'm just going to call it brand A1 to 100 just to make it easy. So that works absolutely fine, of course, and that's something you could do. And indeed, we talked about doing an insert file there to make that a little bit more efficient. So that works pretty well. As I said, you could put that into an insert file, but actually even more efficient than that is to say that I want a global X dollar. I need to edit this very slightly, looking like that, and I need to unset it at the bottom here. So this is actually even more efficient. So what this is saying is that I want to apply these labels to every variable that happens to be the right number of bits in length. So this variable has 8 bits. It has the 5 very good to very poor, it has the net poor, net good, and the not stated. So it has 8 codes. So what it's going to do, it's going to apply those X labels to every variable that is 8 bits in length. It's a good idea to unset that, because if it finds another variable that's 8 bits in length, it will apply it to that. But again, that's a very efficient way of working. It also, of course, reduces your code quite considerably, because you're not repeating these labels over and over again. But again, it will save runtimes for you, and it will reduce the storage, it will reduce the size of the internal files, and make your tables run a lot faster. Alright, so we've done with some things here to make variables more efficient. For the other things I'm going to talk to you about, I'm going to just really basically mention some things here and refer you to other videos rather than repeat what's covered actually quite well in other videos. Now, the next thing I want to look at, and this is something I've seen many times on data specifications, is, let's come down here. I've seen statements like this, and it can reply to serial numbers. So you might say that if Q12 is a 1, define IQ12 as 2. If Q12 is a 2, define IQ12 as 5. So you're assigning some values here. If Q12 is a 3, define IQ12 as 10. And I'll just do one more. IQ12 as 20. So we might be assigning some values here based on a code. So maybe this is a pack that's got 2 in it, this has got a pack that's got 5, this is a pack that's got 3, this is a pack that's got 4, and you want to assign a value to IQ12 based on that. Now that particularly doesn't really matter when there's a string of 4 codes, but there is a more efficient way to write that, And the way that you write it would be something like this. You would say define IQ12 is $Q12, and now in the brackets you would put a value for every code. So it would be 2, 5, 10, 20. If there's a not stated on the end, you would need to add a code for that as undefined probably. So what we've done here is in one statement, we've done what we did in 4 lines. Now, on the surface, that, and probably in this particular case, it makes little difference. It's not that inefficient. But if statements generally are a lot heavier to process than something like that. That is really just trading numbers or values between bits in a variable. It's doing the same thing as the lines above, but it's a much more efficient piece of code. Now imagine if you expand that to perhaps your occasions. Let's say you've got a code you want to assign to each respondent number, or backcoding where you've coded some data and you want to apply some values to lots of different respondent numbers, and let's say you've got 5,000 respondents. What would be 5,000 if statements to assign that value for each variable? And let's say you've got 10 variables, that would be 50,000 in if statements. You could do in one line of code, which would process almost instantly because it really is just shuffling numbers about, and computers are very good at handling numbers. If statements take time to process, so if you imagine that this was rather than 4 lines, was 5,000 lines times 10 variables, 50,000 lines, rather than 10 long lines, the difference in the processing time would be substantial. So again, this is a way of avoiding if statements. If statements tend to be slow. If you've got the odd one, it doesn't matter. But if you put in 10,000 if statements, you will start to get slow runtime. The syntax here is a little bit obscure, but once you've learned it, it's a very efficient way of working. There is a video that covers this subject in a bit more detail, and it's called assigning values to a variable or list. So that's something that really I would recommend doing, and anything you can do to avoid if statements is a good thing. I'm going to finally just cover a couple of things in the table stage. Now there's something I have seen where you've got a lot of mean score tables. I have seen, for example, where you've got lots of rating scales. They need to be filtered for lots of brands. And I've seen people do loops where they go sort of do A equals 1 to 100 rating statements, do B for, let's say, 50 brands, and suddenly in here, I'm not going to type it, but in here you have a lot of tables, and they're using NDIS to suppress the distribution and just get the mean score out. Now that might be a very convenient way of writing it because a loop is effectively doing the work for you, but loops, whilst they offer huge benefits, are quite dangerous things in that, of course, they're going to generate, in that case, 5,000 tables, and then remove all of the distribution if we've got NDIS in there. So F equals NDIS might be in there, and we might have NDIS in there, so it's actually going to calculate loads of tables that really it's not going to use hardly any of the data except the mean score line, and that really is a very inefficient way of working when you just want mean score only tables. Now the better way of doing that is to convert the values to an integer, have one big table, and increment the rows by the value, and get another table that has the number of people that score, and divide one by the other in manip. Now that's a bit more work, but the payback is huge. If you're running a tracking study every month where you've got huge numbers of tables like this, you'll start to get a payback because the run times will be significantly quicker. And again, there's a video that covers that subject in more detail called Summary Mean Score Tables, where that topic is covered. The final sorts of table that I've seen are where you want what we call a value distribution table. So let's say you've got an integer I don't know if there is one in this project. I don't. Yeah, we've got IQ12 now. Let's say for IQ12 you wanted a table of all the values. So it's quite okay to say table 100 is $IQ12 brackets 100 star comma. And if you put the format RNA in there, that will rank the values in ascending order, and we'll get a table of all the values for IQ12. Now again, that's absolutely fine. What this bracket 100 means is allow up to 100 values, different values, that is, not 100 respondents, 100 different values. Now again, I've seen that abused. You're allowed up to 10,000 in there, and what MRDCL is effectively doing is setting up a table with as many rows as you've allowed. So if, let's take a really good example, let's say you're picking up a percentage and it's an integer and it's not any negative numbers, and it only goes to 100%, the number of values that there can be must be between 0 and 100. So in fact there's 101 different values that could in theory be present within your data. That would be a really bad use of MRDCL if you put 10,000 in brackets there, because what MRDCL will do is set up a table of 10,000 rows and say we'll only need 101 or less of these, and then just remove them at the end. So what you've effectively done there is you've given it 10,000 rows that it could have, when in fact all you need is 101 or less. And what MRDCL is going to do is remove those redundant rows, which is going to be most of the 10,000 in fact, and just waste its time carrying a big table with it and processing a big table. And of course one table probably doesn't matter, but again, if you've got something where you're doing it for 100 brands within lots of filters or something like that, for lots of statements, it really is going to be quite an inefficient use of MRDCL, and really you're better cutting that down to what's a realistic number, like 100, 200, 500, 1,000 even, but not 10,000 unless you really need those 10,000 different values. So the final thing that I'd like you to consider, and that might affect efficiency in big projects, is the topic of repetitive blocks of data. So what I'm thinking about here is where you perhaps have meal occasions or trips and you're asking the same, let's say 10, 20 variables about every meal occasion, every trip, or any other activity that you're asking people to record repetitive or give repetitive bits of information. Now, what you can do, of course, let's say you have 20 variables that you're picking up for each meal occasion, and perhaps you're surveying people to ask about a week's meals occasions. If you're not careful, you could pick up 20 times 20 variables. So if there's 20 meal occasions and 20 variables for each meal occasion, that'd be 400 variables that you very quickly have to carry around with you. Now, that can be a very inefficient way of working. It can actually make doing calculations very complex. It can actually mean defining variables from that quite complex and repetitive. So say you wanted to group the foods eaten at each occasion into some categories, that would mean you'd have to repeat that for each of the 20 occasions. It will be cumbersome to change. There is a technique that allows you to process each occasion by sending a piece of code to process each of the occasions and only holding one set of variables, but then recording which occasion it's for, the first, the second, the third, or the 20th, and whatever it might be. Or if it's unlimited, that's equally fine. And I would encourage you, if you've got data like that where there's repetitive blocks of data for the same variables, to watch the video called Hierarchical Data, Repetitive Blocks of Data, and that will teach you the techniques on what that you should adopt for processing that type of data. And that really has a double benefit, perhaps more than some of the other things that have been discussed in this video. Many of the things in this video have made run times efficient, but probably don't make your time too much different. But that particular one will make your life much easier. It'll be much easier to handle that code, because you're not having to make any changes or add variables 20, 50 times, depending how many repeats they are. But in terms of processing, you won't be carrying around so many variables. If there's 20 meal occasions, you'll be carrying around a 20th of the variables relating to the occasions, and that will be a lot more efficient to process in MRDCL. But it is a technique that's a little bit different from anything else, so you do have to watch that video called Hierarchical Data, Repetitive Blocks of Data, to really understand that fully, and it's not covered the actual technique itself in this video. So that completes this video. I hope it's been useful to you. Many of the things will make no difference or little difference to anybody who's doing small projects, but certainly if you're handling a large project with a large number of tables, a large number of variables, a large amount of data, or a combination of those things, really consideration should be given to them. And certainly if it's a tracking study, because you're just going to come up against this and pay for it over and over again if you don't make your runs efficient. We do offer an advice service on these sorts of things. If you require us obviously to get into the depths of the project and really understand it or set up code for you, we would charge a fee for that. But if you can tell me or tell us about the problems that you have, we're always willing to give you general advice if it's not covered particularly in this video. So there's some really good techniques you should adopt. I would actually encourage you to follow the principles of this video on all projects, because then it becomes second nature when you come to other projects. But thank you for joining me on this video. I hope you found it useful, and let's make a difference by making your code more efficient and making your big project run so much more efficiently. Thank you.